Next structural element is column. Column is a compression member. It is one of the structural elements that are pushed together to carry a load. When the load is applied on the column, it try to pushes that member. So that is why it is called as a compression member. Columns are subjected only to axial compressive force. The loads are applied on the longitudinal axis through the centroid of the member cross section. You can see here the loads are applied on the longitudinal axis through the centroid of the member cross section, and the load over the cross sectional area gives the stress on the compression member. For column, the principal stress comes mainly from axial force. So axial force is the predominant factor in columns. So in addition to that, we will be getting moment as well. First, let's see what is axial load in column. It is a force with its resultant passing through the centroid of a particular section and being perpendicular to the plane of the section. As you can see, the load is acting at the centroid of the particular section. So there are two types of load. One is concentric load and the another one is eccentric load. If the axial force is acting through the centroid of the member, that is called concentric load. See, this load is acting exactly at the centroid of the member, so it is called a concentric force. If the axial force is not acting through the centroid of the member, that is called eccentric load. That means this load will act some distance from the centroid of the member. So in that case, that becomes eccentric. So due to that eccentricity, the moment will develop in the column. If the axial force is not acting through the centroid of the member, you can see here this load is acting some distance away from the centroid of the member. So that load is called eccentric load. So due to this eccentricity, we will be getting moment in the column. Next one is axial load with uniaxial bending. So if the load is acting some distance away from the CG of the member, then it will get axial load along with bending moment. So that is uniaxial bending. So here axial force P is not acting on the centroid of the member. It is said to be eccentric. So that eccentricity we can call it as EX. Due to that eccentricity, a moment will develop in any one axis of the column. So if it is acting away from the member in the X direction, so the moment will be in X direction. If it is acting away from the Y direction, we'll get the moment in the Y direction. So bending takes place on any one axis of the column in uniaxial bending. Next one is axial load with biaxial bending. Biaxial bending means the load will act away from both axes. That means X axis as well as Y axis. You can see here this load is acting away from the X axis as well as Y axis. The axial force P is not acting on the centroid of the member, so this is eccentric. Due to this eccentricity in both axes, moment will develop in both axes of the member. So in biaxial bending takes place on both axes of the column. So columns are compression members. It is mainly designed to resist the compressive force. So here you can see the reinforcement arrangement in column. So these are the longitudinal reinforcement. The vertical bars are the longitudinal reinforcement to resist the compressive force, and these are called main bars, and these ties are called the lateral ties. These ties are provided to hold the longitudinal bars in position. Next, let's look into the types of column. Based on shape, the column can be square, circular, rectangular or L-shaped columns. Based on type of loading, it can be classified as axially loaded column, axial load with uniaxial bending and axial load with biaxial bending. This I have explained you before. Based on slenderness ratio, we can classify the column as long column and short column. When the ratio of effective length to its least lateral dimension is less than or equal to 12, then the column is said to be short column. When the ratio of the effective length to its least lateral dimension is more than 12, then the column is said to be long column. So when we design a long column, what we have to do, we need to consider some additional moment that is given in the SP16 code. Slender compression member, this is given in SP16, design aid for concrete member. So here the additional moments are given for the slender columns. That is, you can see here. When a compression member is slender with respect to the major axis, an additional moment MAX given by the following equation should be taken into account. See, this has to be taken. So according to the axis of the column, major axis and minor axis of the column, we need to consider this additional moment PUD by 2000 into LEX by D the whole square. Similarly for other axis.